So the first thing is you have to assume the buckling shape or the slightly bent shape. Yeah. This is, but if the buckling shape, this might be given to you. Okay. If it is not given, ask you to assume, you have to assume. If it is given, then you have to use the one given. Maybe it's given to you, B is equal to A cos pi x over L or something like that. So you have to use that. Okay. Depending on the question. Okay. The next one after that, you have to form the phi p, which is UP plus VP. And the UP here will be half EI X. If EI constant, then you just take it out, and then VP will be, don't forget, negative. This is integrate 0 to L half of what? E. So this basic one, don't forget, okay? Negative half P dV dx square and negative half dEI d2V dx2 square. So here, don't you have to don't make mistake in the differentiations first. After that, integrations. So integration sine, cosine, sine square will be involved if the assumed buckling shape give you in terms of sine and cosine. Then you are going to get a square term here. So you need to know how to integrate square of sine and cosine. Okay. Then what we do is we apply this, which is principle of minimum potential energy. Then we have del pi p, del the degrees of freedom, whatever degrees of freedom that we have equal to 0. Okay. And from there, we are going to apply the non-trivials. From here, you have to apply the non-trivial solution. Okay. Which is the determinant of whatever that we get. Okay. You are going to get a simultaneous equations. You are going to get a matrix equations depending on the degrees of freedom. The matrix equation might be two unknown. If you have 2 degrees of freedom, then after we get this, you get an equation, matrix equations, then the coefficient matrix, the determinant of that must be equal to 0 in order to get the P critical. So basically, it is the things that you have to evaluate is very similar to Valery's method that we use in EAS661. The only thing, the purpose here is to find P critical, not to find this. In 661, in structural mechanics, we want to find this, to find the solution of the deformed shape. But in this 663, we apply Valery's method not to find this. This is remain unknown, indeterminate, but we want to find what is the P critical. So the things here to be aware of is, don't forget how to get this. This is a strain energy for bending, half EI. If EI is constant, then just take it out. And then you have to differentiate this assumed shape twice, then square it. Don't forget to square it, then after that, integrate. The second one is this potential energy of the axial force. There must be a negative half, then whatever axial force multiply with, differentiate this once and then square also. Okay. Then the next step is applying this principle. Then that means from this equation here, you are going to partial differentiate. If it's only one, if there is only one here, then only one equation. If there are two, then you have two equations similar to Rayleigh-Ritz method. Then finally you apply these conditions, then you solve for P critical. Okay. So that is the main idea behind Rayleigh-Ritz method. Okay. So Rayleigh-Ritz method is time. It is follow this procedure, but you need to evaluate this. So the time-consuming part will be doing the differentiation and then integrations. So differentiations, integrations, you have to be familiar, get very fast. If you have to integrate sine square, how do you integrate sine square? Integrate cosine square. How to integrate cosine square? Because if you have this one dv dx, this one become negative a sine. You square it, it becomes sine square. How to integrate sine square? Okay. You need to be familiar. Okay. So Rayleigh-Ritz method is basically, I think, very straightforward. I think only thing you need to be familiar with differentiation integrations. Okay. And then finally here. So the buckling shape or the slightly bent shape, if you need to assume, then you have to make assumption. Yeah? If you don't already given to you, then use it directly. So that is the main thing about Rayleigh-Ritz method. And in your assignment also, you already solved one Rayleigh-Ritz method. Okay. And some of you solve using another form, which is UP is equal to half m squared over EI. Okay. This one, there are two ways to write. So you can make use directly of this. Okay. This is what I covered. So, but this one is if you can get the bending moment, that will be more accurate. But please use this directly. Okay. But there are two ways of writing the strain energy for bending. One is using the displacement, the other one directly using the bending. But in the class, I cover this because this is based on assumed shape. Directly, we make use of the assumed shape. Differentiate twice, square it for this. Differentiate once, square it for this. So that is on Rayleigh-Ritz method. So Rayleigh-Ritz method, I think the only thing that I would like to remind you all is, again, don't forget how to differentiate sine and cosine, and don't forget how to integrate sine square, cosine square. If this is x, if this is a polynomial, it's easy. X square, x cubed is easy to integrate. But sine square, x square, you need to be fast how to integrate cosine square and sine square. Okay. So let me